Let's do the constant acceleration worksheet number 4, problem 4. And here's the worksheet here, and here's number 4. It says a bus moving at 20 meters per second begins to slow at a rate of 4 meters per second every second. How long does it take for the bus to stop? How far did it travel while braking? And draw velocity versus time graph. So, given. Here's the ground, nice level ground. Here's the bus. Here's the awful diesel coming out of the bus. And it is moving at 20 meters per second. So the initial velocity is 20 meters per second. And the acceleration is 4 meters per second squared, but it's slowing. So what should I put on there? Yeah, the velocity is in this direction, but we're slowing, so the acceleration needs to be in the opposite direction, so it's in the negative direction. And we want to know how long does it take for it to stop. So here we are at a stop. So we want to know how much time that takes. So actually, in terms of what's given, B final equals 0. So what are we trying to find? A, it says, how long does it take for it to stop? That's the time. And then B, how far did it travel while braking? I'm going to call it delta x. And C, we just want to graph the velocity versus time. So let's solve it. Well, I want time. What am I given? Initial velocity, final velocity, acceleration, and I want time. So I'm not given delta x, and I am not asking for it yet. So I want the kinematic equation that doesn't have delta x on it. Which one is that? It's the first one. So as you do these problems, keep that little equation list handy. Have those 4 kinematic equations right there, and you can figure out which one you should use to solve the problem. So now I'm going to solve this for time. I'm going to do it in one step. Time is equal to, well, it's v minus v naught, right? Because I got to subtract this to the other side, divided by the acceleration. Now I can plug in values. My final velocity is 0. My initial velocity was positive 20 meters per second, but it's v minus v naught, so minus 20 meters per second, divided by the acceleration, but that's negative 4 meters per second squared. And this is good, this is negative, because the negative cancels the negative here. And 20 divided by 4 is 5. The meters cancels the second squared. And I've got 1 over seconds. Reciprocate and multiply, I get seconds. So the time equals 5 seconds. And that's my answer for part A. Part B, I want delta x. Now I could use the 5 seconds and get the right answer. But what if I made a mistake in part A? I don't want to carry that mistake in part B. So I'm going to use the kinematic equation that doesn't have time in it. And there's only one, and that's the last one, number 4. V squared equals v naught squared plus 2a delta x. And I'm going to solve this for delta x. Well, first of all, I know this is 0. And so I'm going to solve this in one step. If you need to take your time and go through the algebra more slowly, go ahead and do that. I'm just going to put this over on the other side. Subtract v naught squared and divide it by twice the acceleration. And now I'm going to plug in my values. Well, v naught is 20 meters per second, but you have to square it. And notice that this negative is not in this parentheses. This comes from the subtraction to the other side, so don't square it away. Divided by 2a, 2 times negative 4 meters per second squared. So here I've got a negative here from the subtraction. I got a negative here from what's given. They cancel each other out. 20 times 20 is 400 meters squared per second squared. Notice that I'm not just squaring the number 20. 20 times 20 is 400, but I'm squaring the units. Everything gets squared. Divided by 2, and then 4 meters per second squared. Well, 400 divided by 4 is 100. 100 divided by 2 is 50. Meters cancels the meter squared. Second squared cancels all the second squared. I'm left with just a meter right here. And in fact, delta x is measured in meters. And you get 50 meters. And that's my answer. Does that make sense? Woohoo! Now let me show you this. We're going to take this and we're going to do part C, and I need more paper. So I'm going to graph the velocity as a function of time. Now I do have to use the fact that it's 5 seconds. So this is part C. And so my time is going to go from 0 to 5, 1, 2, 3, 4, 5. Time in seconds. And then velocity, well, what is it? It starts at 20 and goes to 0. So I'm going to go 5, 10, 15, 20. And then I'm going to say, oh, this is velocity in meters per second, because I don't want to lose half a point. Now, start at 20, and then we steadily go to 0. And I know this is going to be a straight line, because the acceleration is a constant. And that's my graph. Now I can check to see if it's right. Look at the area underneath this graph. Well, this is 5 times 20 is 100, divided by 2 is 50. So the area underneath this graph is 50 meters. Yay, that matches my displacement. All these things have to work together. And there's the complete problem. You didn't actually need to do this. It didn't ask you to do it. I'm just using it to check my work. And that is problem number 4. Any questions? Okay, star and question mark it. That is all.